Tom Butler, your line is open.
I was wondering what climate that analysis was run for.
So for this climate, it's actually Chicago.
Great, thank you. Have you done it for others, say Atlanta or some drier climates?
Yeah.
More heat?
Yeah, it's just not shown here, and since the purpose of this webinar is not to dive into the detailed results discussions, but you can certainly choose to run within any climate.
Great, thank you.
Mike Eslick, you may ask your question.
Hey, Shaw, this is Mike.
Hi, Mike.
I have a question on undersized systems. So I'm thinking in a retrofit scenario, say we know we have the design documents for a system and it's well below what current best practices, what's going to be the impact?
When you say undersize the system, are you...
Sorry, yeah, board on heat exchanger length, so foot per ton.
Right, so if you have undersized the system, I think the first impact is in some climate, including in heating-dominated climate, if you don't have a electric resistance heater, there's a potential for freezing the ground if the control is not properly done. And also in climate that's not balanced, you are going to see really a degradation of performance throughout the years. Severe degradation of the performance throughout the years because you are without enough heat exchanger length, you can either charging the ground, continually charging the ground so the temperature keeps on rising, or continually discharging the ground so the temperature keeps on dropping throughout the years. So you won't be able to see steady performance.
Is the model smart enough to, does it pick up on that, or is that just practical?
So in BEopt, if a user chooses to chooses to hard size every parameter on the ground heat exchanger, he can run for 1 year simulation. However, a warning message will show that it is a user's at his own discretion that there's a high potential of the system is undersized, that 1 year's simulation results does not really represent a steady state. And also, if a user is really interested to see 30-year performance, or perhaps in an existing installer situation, you can use BEopt Energy Plus to run one simulation and generate a energyplus.idf file, and then you have to, to change within the IDF file to 30-year run simulation period, and actually to see the performance degradation.
Thanks, Shaw.
Yeah, but user can always contact us if there's any questions on that.
So, Shaw, for properly sized systems, does BEopt account for making a performance adjustment for the long-term 30-year performance versus 1 year?
So the simulation results, the adjustment is actually done in the annual ground load imbalance. So we adjust the heat exchanger size based on the effect, based on the annual load imbalance. Pretty much is accounting for the 30-year long period modeling. Any other questions?
Yes, we have a question from Jean Ping. Oh, actually, that question just disconnected. No questions at the time.
All right. Moving on.
I'm sorry, we just did get another question, ma'am. One moment.
Okay.
Sir.
Hello?
Hi.
Yeah, this is Xiaobing Liu from
Xiaobing.
I just have a question regarding auto sizing for the ground heat exchanger part.
Right.
Do you mean you use some rule of thumb? Because I see from the option you have several design criteria such as how many feet per ton for certain conditions. Does you use that to size your heat exchanger, or you run simulations iteratively until you get the size that can satisfy some predefined temperature? of the loop?
So with that iteration that you are talking about, it's going to really consume a lot of runtime.
Okay.
So what we did is actually sort of a simplified approach when accounting for the annual load and balance. And we do define a chill water design temperature and as well as heating water design temperature based on the peak design conditions that varies with individual climate. When we did the sizing criteria, we actually referred to the GLEPro as well as LoopLink. We actually we did quite a few runs with different climates and actually compare the results to make sure it is within very decent agreement. So I hope that answers your question.
Okay, yeah.
So it is not an iterative run. We did some simplification.
Okay.
However, we did compare the results with representative and mostly like continental climates and compared against GLEPro to see the results, how good alignment it is between BEopt and GLEPro.
Okay, another question is, you mentioned that for the two-stage heat pump, you have some issues with both DO2 and NH+. I don't know exactly what the issues is, but why develop that ground heat exchanger ground source heat pump module for DO2? Actually, I have input the two-stage heat pump performance curve into the DO2 as an external library. So I don't know whether you have take a look at about that external libraries for the two-stage heat pump performance curve.
Yes, we have. So in DO2, the default modeling, when it goes to the two-stage, it pretty much takes one performance curve across the entire operating range, and also it takes the total capacity instead of a sensible capacity. So I think this problem existed for the heat pump as well as AC for two-stage as well. And in heat pump and AC categories, we actually use the Energy Plus. We revised the input based on the Energy Plus model, and but in the case of ground source heat pump, in Energy Plus model, in the case of ground source heat pump, everything is DO2 based because Energy Plus, in terms of proper modeling of ground source heat pump, is still lacking. So.
Oh, okay.
Yeah.
Is there any plan to improve the Energy Plus simulation for ground source heat pump?
Yes, we have filed 2 tickets to the Energy Plus team. One is actually regarding to the superheater proper sizing, and the other one is actually is regarding to the horizontal trench model. And I think this two-stage. Well, thank you for mentioning this two-stage modeling that we will also report to the Energy Plus team.